So section 4.6 is all about isosceles triangles. Now isosceles triangles, the word isosceles comes from the Greek root iso and skelos. Iso means same and skelos means legs. And so when we talk about isosceles triangles, we mean the legs are the same. Just like these legs in this triangle would be considered the same. So now let's talk about some parts of isosceles triangles. First off, the base of an isosceles triangle is the one side length that isn't congruent with the other ones. The two legs, of course, are the sides that are congruent to each other. So there's a leg and another leg. So the angles that are connected to the base are called the base angles. The side or the angle opposite the base is called the vertex angle. And vertex, if you care, that the plural of vertex is vertices, not vertexes. So here we have another isosceles triangle. You can see the two legs are shown in red. We have the base shown in blue. The base angles are shown, the vertex is shown, and we have a theorem about isosceles triangles. And that theorem says if we have two sides of a triangle congruent, in other words, if we have an isosceles triangle, then that isosceles triangle has congruent base angles. So that means that these angles will always be congruent to each other. So, in other words, if you have an isosceles triangle, then the base angles are always going to be congruent. Let me pull that up for you. So we can use that to solve some problems. Let's work on a quick, actually, before we work on that example, one thing about this theorem is its converse is also true. Remember, the converse of an if-then statement takes the hypothesis and changes it around with the conclusion. So the original theorem was if two sides are congruent, then the base angles are congruent. The converse would be if the base angles are congruent, then the sides are congruent. In other words, if the base angles are congruent, then we know we have an isosceles triangle. So the biconditional says two sides are congruent if and only if the two angles are congruent. So let's use that to solve some problems here. Here I have an isosceles triangle. The reason I know it's isosceles is there are these congruence marks on the legs. So remember, isosceles triangles, if the legs are congruent, then the base angles are congruent. So here's the base of the isosceles triangle. So that means these are the base angles, and those are congruent. In other words, x and y are equal. Now, using the triangle sum theorem, all three of these angles need to add up to 180, which means x and y together, well, 180 minus 120 is 60 degrees. And so angles x and y have to share 60 degrees equally. So x and y are the same. If we divide 60 by 2, then we get 30 degrees. So each angle x and y is equal to 30 degrees. Let's take a look at another example. Here I've got, well, I know I have a right triangle, but I don't have any congruence markings to indicate that it's isosceles. However, since both of these angles say x degrees, that means those two angles must be congruent. And just like we saw in the previous slide, if the angles are congruent, then the sides opposite them are congruent. In other words, if the base angles are congruent, then I know I have an isosceles triangle. So that means these two legs are congruent. Well, those congruence marks show me that y must also equal 3. Now, how are we going to find the red angles? Well, we'll do it in kind of a similar way that we did in the previous problem. Since both of those angles must be congruent, and this angle is 90 degrees, the rest of the two angles must share 180 minus 90. And so both of those angles, that angle and that angle, are 45 degrees. Again, because of the triangle sum theorem and also the theorem about angles in isosceles triangles, we know we can just subtract from 180 and divide by 2. Here we have one more problem dealing with the base angles in an isosceles triangle. I know it's isosceles because these little congruence marks exist. With isosceles triangles, base angles are congruent. Those are the base angles because that third side would be the base. And so since base angles are congruent, I know that those angles must equal each other. 3x minus 5 must equal 5x minus 43. So then let's solve for x. I'll subtract 3x from both sides, add 43 to both sides, and lastly divide by 2 on both sides. So then there's one last little thing with this particular problem. We found x, did it, and now we need to classify the triangle by its angles. So it's either acute, right, or obtuse. So let's take this value of x and substitute back into angles k and angle m. So we need 3 times 19 minus 5. And so that means angle K is 52 degrees. Likewise, angle M is 52 degrees because base angles are congruent. And so this third angle, angle L, well, right now it's unknown, but because of the triangle sum theorem, I know that the measure of angle L plus two angles that are 52 degrees must add up to 180 degrees. And so we can solve for the measure of angle L. So this angle is 76 degrees. So each of the three angles, 52, 52, and 76, all of those are acute angles, and so we can classify this triangle as an acute triangle. Earlier we talked about equilateral triangles and equiangular triangles. And we had this theorem from the first day's notes. A triangle is equilateral if and only if it is equiangular. So here we have an equilateral triangle. We can tell because of the congruence marks. And so that means each of these three angles must be congruent. So if all of the angles add up to 180 and 3 are congruent, then 180 divided by 3 is 60 degrees. So each of the angles in an equilateral triangle, equiangular, are 60 degrees. So let's take a look at this theorem a little bit more and apply it to some problems. So right now, this triangle, well, what kind of triangle is it? We have congruent angles, angle R and angle T. And what that tells me is I have an isosceles triangle for sure. It's guaranteed to be an isosceles triangle, and in particular, since these are base angles, then RT is the base, and so RS and ST would be the congruent legs. So let's solve for y, and we can only use those pieces of information to solve for y, right? Because they're, even though it's tipped on its side, those are the legs of the isosceles triangle. So since legs are congruent, 6y plus 5 is equal to 7y minus 13. So let's solve for y. First, let's subtract 6y from both sides, and then add 13 to both sides. So we have y is equal to 18. Now, if y is equal to 18, and it says we're to classify this triangle by its sides, well, we know for a fact that it's an isosceles triangle, because these base angles were congruent. However, it's possible, remember an isosceles triangle could potentially be an equilateral triangle if all three sides are congruent. And so let's take this value of 18 for y and substitute that value in for each of these three side lengths. So sub in y equals 18 for these three sides. So for each of these, 6 times 18 plus 5, that's 113. 8 times 18 minus 13 is also 113. Not a surprise there because those are the congruent legs in an isosceles triangle. But this blue statement, 5 times 18 plus 23, is also equal to 113. And so what that tells me is all three of the sides are congruent to each other. And so triangle RST, it's not just isosceles, it's actually equilateral. Here's one more example problem that's pretty similar. What I'd like you to do is, if you're feeling pretty confident, push pause and try this problem on your own. All right, let's walk through the description of the problem. We know that triangle CAB is isosceles. And in particular, A is the vertex angle. So A is the vertex. That means that B and C are the base angles. So B and C are congruent, and then the sides opposite B and C would be the congruent legs. So the side opposite B refers to that segment, AC. The side opposite C refers to the segment AB. And so that means 3n plus 46 and 12n plus 10 must be congruent. So we'll go through and solve for n. I'll subtract 3n from both sides first. Then I'll subtract 10 from both sides. And lastly, dividing by 9 on both sides gives us a value of n. N is 4. So we found n. That's done. Now we need to classify the triangle. So in order to classify the triangle, we need to figure out how long its sides are. So we'll take that value of n and we'll just substitute it in to each of the three side lengths. 3n plus 46, 12n plus 10, and 8n plus 21. So 12 times 4 plus 10, that's 48 plus 10 is 58. And likewise, 3 times 4 plus 46 is 58. Now the one that we're not exactly sure about is this base side length. 8 times 4 is 32, and 32 plus 21 is 53. And so that means this side length CB is not congruent to the other legs. And so therefore, when we are to classify this triangle, CAB, all we know is triangle CAB is isosceles. And so in response to the question, is triangle CAB equiangular? Well, no way. And the reason it's not is a triangle must be equilateral to be equiangular, and this is not equilateral, so therefore it's not equiangular.